So everybody listening, here we go. So it says simplify. This is the square root. So simplifying the square root. What we can do is take our calculator, type in the square root of 400. If it comes out a whole number, we're done. Like, we're good with that. But if it's a decimal, we go back and break it down and pull out group sub 2, right, everybody? But if it comes out a whole number, you might as well use your calculator. Square root of 400 is 20. So we've just simplified the square root of 400. Now we're simplifying the square root of x squared. There's two x's, so how many groups of 2? So we'll pull out an x. 2 divided by 2 is 1, right? And then 6, we're looking for how many groups of 2 are there in y to the 6? 3. So 6 divided by 2 is 3, y cubed. So that means we simplified everything and nothing stayed under the radical. It all came out. So that's the answer. Now in the instructions it says use absolute value signs when necessary. So remember, think about it, you guys. If we're taking a square root, our answers are never going to come out negative, right? There's no such thing as a square root and getting a negative answer. It's either I or positive, right? Square root of a negative number is I. Okay, so we've got to put absolute values to and say that this is my answer, but if I put a -1 here, that's -1, and that wouldn't be allowed. Negative x's aren't allowed. So we've got to put absolute values. Now here's why. So the rule is if you have an even root, right, and then odd exponent in your answer, then you've got to put it. So 1 and 3 are odd. So our final answer would be 20xy cubed. And we can just put it around both of those like that. Remember doing that, everybody? Okay. Sweet. So do problems 1 through 6. I'm going to give you like a couple minutes. Fly through them. Odd roots can have negatives underneath. They'll just have negative answers. Remember that, because I still saw people on the final putting I's on odd roots. Next section says simplify. Now remember, simplify means add, subtract, multiply, or divide. So everybody, look at number 7. This one's division. Now notice we have 2 radicals. Anytime you have 2 radicals and they're the same radical, your first step is to put the radicals together and simplify everything underneath. Square root, so we can put them under the same square root. So we have 200x cubed y on top, and on bottom we have a 2xy to the 5th. Is everybody feeling okay about that? So now simplify underneath the radical here. So 200 and 2 do simplify to be, make sure you put things in the right places, 100, right? X to the 3rd divided by x. That's x squared on top, right? So let's write it as x squared. Now y and y to the 5th is y to the 4th on bottom. So now rewrite it. We have the square root of 100x squared divided by y to the 4th. Now remember, from here, you split it up. So we have the square root of 100x squared, so you're splitting it back up, divided by the square root of y to the 4th. Now, here's the thing, though. We need to make sure we simplify all of our radicals before we try to rationalize it, right? Okay, so let's just focus on the top. Square root of 100 is 10, square root of x squared. And on bottom, square root of y to the 4th. Y squared. Now looking at that, do you see how we don't have a radical any longer, and so we're good? If we would have gone about it the other way, we still could have got it right, but it would have been a nightmare. Which this was an easy one. Okay, next one we're going to do is 13. It says simplify. You're either adding, subtracting, multiplying, or dividing. This one's division. Now notice, none of the radicals simplify. There's only one radical. Nothing simplifies here. So why are they telling us to simplify? There is a problem. What is it? There's a radical on the bottom. Tell me this. Will this fix it? Square root of 2 times square root of 2. That won't, because then wouldn't we put parentheses around that, and then we're going to have that square root of 2, and now that just made the problem worse, right? So that's not what we're going to do. How do you fix something with a radical on bottom with 2 terms? Conjugate. Love the word conjugate. Way to go. So we're going to multiply by the conjugate, which means same term, change a sign in between. 1 minus the square root of 2. You do it to the bottom, you have to do it to the top, otherwise you've changed the problem. So now there's 2 terms, so you need parentheses. 2 times 1 is 2. 2 times negative root 2 is negative 2 root 2. Now does any of that simplify? Can we combine those? No, that's like an apple and an orange. You can't combine them. And then our radical doesn't simplify. On bottom, we have 1 times 1, which is 1. I'm going to go over here. 1 1 times negative root 2 is negative root 2. Square root of 2 times 1 is positive square root of 2. Square root of 2 times negative square root of 2 is negative square root of 4. So we have 1 minus 2, right, everybody? 1 minus 2, which is negative 1. So your final answer, because anytime we divide by negative 1, you'll divide each of those by negative 1. So 2 divided by negative 1 is negative 2, right? Negative 2 divided by negative 1 is positive 2 root 2. So this would be how we would write our final answer. Hey, awesome. What I want you to do is 7 through 15. Ready, go. Problem, it says simplify. That means add, subtract, multiply, or divide, or properties of exponents. So looking at this one, it's just division with properties of exponents, right? So take my suggestion. It's actually raised to the 3/4 power 2, right? 3/4. Take my suggestion, everybody. What you need to be doing is saying, okay, we have all this stuff to the 3/4 power, but what we should do is look at our parentheses and simplify first. So focusing on the inside here. The 16 and 81 simplify. Actually, type it into your calculator. I want you all to do it. Ready? 16 divided by 81. Hit math, enter, enter to change it back into a fraction. Okay, so it didn't simplify, so we'll rewrite it. Now, x to the 5th and x to the 4th on top or bottom. It's important, okay? Right? And then, y to the 10th divided by y squared is y to the, nope. 8 on top, right? When you divide, you subtract top from bottom. 8. Okay, does everybody see that? And now all of that is raised to the 3/4 power. So a couple of things to remember is that this 16 is raised to the 1st power, this 81 is raised to the 1st. We're taking powers and raising it to a power. So we, what? Multiply. No. When you raise a power to a power, then you, okay. So we have 16 to the 3/4, right? We have x to the 4 times 3/4. Now look, you guys should be able to see this. 4 times 3 divided by 4. 4 divided by 4 is 1, correct? So it's x to the 3rd. Now let's say you didn't see that. Type it into your calculator. 4 times 3/4. It's 3. Now 8 times 3/4. 8 times 3 is 24 divided by 4. Yep, so we have a y to the 6th, that's on top. And on bottom we have 81 to the 3/4, correct? Now what I want you to do is take your calculator and simplify that. Go, type in. Now I want to see this. You should all do it, not just watch. Type in 16 caret parentheses. 3 divided by 4. Why aren't your grimy little fingers typing on your calculator? What do you get? Now here's what's important, that you use parentheses around all of that exponent. Okay, so that became an 8. Type that into your, what makes no sense? How to type it in? No, it does make sense. That's the 4th root of 16 to the 3rd power. Okay. This becomes 27. So we would write it all pretty style. 8's on top, x is on top, y to the 6 is on top. I meant to say x to the 3rd's on top, and then 27's on bottom. So it looks harder than it was. You've got to simplify in sections. It is doing that. We're just using our calculator, because if it came out a whole number, and it did, we would just want to use our calculator. If it was a decimal, we'd go back and do this. Yeah. 4th root of 16 to the 3rd? Yep. No. Oh, yeah. Yeah, you could do that, but that would be a long way of doing it. But you could actually rewrite it like that, but that would just be the long way of doing it. Okay, number 19. It says simplify. So what you do is focus on your parentheses. Does anything simplify in here? No, right? So then we go, no, let's not do that. We flip-flap. So this is 4 to the 1st power. We're raising powers to a power, so we multiply the powers. So we have 4 to the negative 1/2. X to the negative 2 times negative 1/2. Positive 1. 4 times negative 1/2 is negative 2. So you'd say that's my final answer, but it's not acceptable because we have negative exponents. any base to a negative exponent, the whole base, not just the exponent, the whole base flips over a fraction, and then the exponent becomes positive. So we're fixing that. So now on top we have an x left. On bottom we have 4 to the 1/2 power, which means the square root of 4, right? Which is 2. And then we have our y squared. Then you say that final answer looks good to me. Because nothing, no negative exponents, nothing more we can simplify, nothing more we can do. Okay, awesome. Don't forget your properties of exponents. Do 16 through 21, go for it. This one says solve. Now notice when it says solve, it has an equal sign. We never solve unless we're told to solve or given an equal sign in the equation. Equal sign means solve. So what we do is isolate the radical, undo the radical, then solve for x. Then we always check when solving extraneous solutions. So what should we do to get rid of the radical? Cube both sides of the equation. Over here, root cancels out with power. We're left with x minus 3 equals 1 cubed. Remember that 1 cubed is not 1 times 3. It's 1 times 1 times 1, which is 1. So then our last step is add 3 to both sides. X equals 4, we better check it. Plugging that back into the original. We have the cube root of 4 minus 3. Does it equal 1? Cube root of 1 equals 1. 1 equals 1. So we get to keep it. That one worked out nice and pretty. Okay, let's do another one. Number 27. So the first thing we did in this class was learn how to rewrite it as a radical. Question for you. This is important. Is 3 raised to the 4/3 power? No. So this is 3 times the roots are on bottom. Remember the picture of our flower? Okay, roots are on bottom, so cube root, power's on top from the sun, x plus 1 to the 4th. That equals 48. Now you've got to do this in the correct order. The first rule is to isolate the radical. Nothing multiplied, nothing added. Divide both sides by 3, right?
Interruption. All radicals be independent forever.
So we have the cube root of x plus 1 to the 4th power equals. Okay, next step, how do you undo the cube root? Cube both sides. So this cancels out with this. We're left with x plus 1 to the 4th power, which equals 4096. Right? Now what's our next step? Fourth root of both sides of the equation to undo the radical. Didn't we just take an even root? And we're not going to forget, when solving and taking an even root, we need the plus or minus answer. Root cancels out with power. We have x plus 1 equals plus or minus. Type in. I want to make sure you know how to type this into your calculator. 4. Then hit math. Then go down to the x root. So that's 8. Not only 8, but it's plus or minus 8. Because remember that a lot of us missed that. So now from here, split it apart. We have x plus 1 equals 8. Positive 8 and x plus 1 equals negative 8. Solve for x in each case. Subtract 1, subtract 1. X equals 7? No. Minus 1, and x equals negative 9. Now we need to check and say, are both of those solutions, is one extraneous or is both extraneous? So let's go back to the original problem. I want you to all type this into your calculator. So the original problem was this. Type in 3 into your calculator, put a parenthesis. Let's plug in 7 in for x. 7 plus 1, and then caret parentheses. 4 divided by 3, close your parentheses. Hit enter. It equals 48. Okay, do the other. We're checking that's 48, so that one worked. Because that's a true statement. It was supposed to equal 48, and it did. Okay, now type that in. You've got to use parentheses just how I wrote it. It's 48, so neither of those happen to be extraneous. So we keep both of them. Okay, do 22 through 27 go. 29, it says, given f of x is this function and g of x is this function, it says find f minus 2 times g. Guys, do not make these harder than they are. Just do what it says. Take function f, which is x squared plus 5, subtract it to 2 times function g. 2 times all of function g. Does everybody see how it's that easy? So that's x squared plus 5, distribute negative 2 through, so negative 2x plus 14. Put our final answers in standard form. Now here's the thing. We are not solving this. There was no equal sign. It said nothing about solving. So x squared minus 2x, 14 plus 5, 14, 15, 16, 17, 18, 19, right? Do not solve. It didn't say solve. There's no equal sign here. We simplified. That's our answer. Now it asks us the domain. It's going to ask that. The domain. Well, guys, what domain means left and right. What's your function doing? It's a quadratic. What does a quadratic do from left to right? Grows forever, right? All real numbers. Hey, true. Now, when are we going to have a domain that is not pretty? If we had x plus minus 3 over x plus 2. The domain would be all real numbers except x cannot be negative 2, right? Because we just can't divide by 0. But usually, besides that, we don't have any problems. Okay, 32. It says find f of g of x and g of f of x. I can promise there's one just like this on the test. So, here's f of x in 32, here's g of x. So what I want you to do is you have to be able to get this right. It's going to be very specific on the test. F of g of x means f composed of function g of x. So remember how to rewrite it. Squish x back in with g, that's g of x. Squish it back in one more time, f of g of x. So isn't this one substituting in g of x into the other function? Yeah. Wherever there's an x. So look, 1, 2 places, correct? So instead of an x, there's 2x squared minus 5 times 2x plus 2. So simplify it. This squared is 4x squared minus 10x plus 2. We've combined like terms. We've done f of g of x, right? Let's go the other way. This one's now saying g of f of x. So squish x back in with f. That's f of x. Squish it back in again. That's g of f of x. So you should be substituting in function f of x into the other function wherever there's an x. So instead of an x, there's that. So isn't that 2 times x squared minus 5x plus 2? Does everybody see how I did that? Right, this one goes in over there. So then our final answer for that, we would distribute. We're not solving though. So that's 2x squared minus 10x plus 4. And we're done. We found g, f of g of x, f composed of function g, and we found g of f of x, taking function g and composing a function f. So on the test, I'm going to say this equals what? Like you're going to have to know which one's which. Okay, do 28 through 40 evens, only evens. You don't have to do the odds. If you do the odds, I'm going to give you, if you do all the problems on the test review, if you do every single last problem, I'm going to give you a 2% increase. Now remember that other 5% increase is also available. Remember the bonus test review. Okay, go. So do 28 through 40 evens. You might want to write that down so that you don't do extra if you don't care about bonus. Okay, it says number 41. So this is where we get into what we've learned this far new. But I'm telling you, there's going to be every type of problem on the test. Here we go. 41. It says find the inverse. Is the inverse a function? Find the domain and range. So it's an equation. How do we find the inverse of an equation? Switch y and x. So we have x is equal to y plus 2 squared minus 4. Now solve for y algebraically in the correct order. First step. Add 4 to both sides of the equation. You should all be doing this. So we have x plus 4 equals y plus 2 squared. Then what would we do? Square root both sides of the equation. Isn't the original a full quadratic? So don't we need a plus or minus? Okay, so we have plus or minus the square root of x plus 4 equals y plus 2. Next step. Subtract 2 from both sides. It's negative 2 under the radical. So y inverse equals plus or minus the square root of x plus 4 minus 2 like that. Correct? Yeah. Okay, now let's do is. It says is the inverse of function. Isn't this plus and minus? Think about this. If we reflect a quadratic, is it going to be a function? Nope, so we'd say not a function. Now let's do the domain and range. This is going to be on the test. So let's just look at the original problem and do a rough sketch, a correct rough sketch Isn't this shift, don't forget your shifts, guys. Shifting for all functions works the same. Left 2, down 4, correct. Left 2, down 1, 2, 3, 4. So I'm drawing a rough sketch, and then it's an upward facing quadratic. It can be a rough sketch for domain and range. Because this just helps us. So what's our domain of the original? Left and right, it's all real numbers. So then what's the range on our inverse? Good. Now let's do the range on our original. The lowest y value is -4, and it's growing to infinity. So our range is -4 to infinity. So then our domain of our inverse is -4 to infinity, guys. Do we know what we're doing? Okay. Okay. Awesome. Now I just want to show you, if we were to graph this, nah, we don't have time. Okay, 47, graph by the domain and range. So this is what I would expect on the test from you. This is really, I will expect a perfect graph. So what you should do is say, what is my parent function of this? Square root of x. I'm going to do it this way so that I don't mess up on accident. So we're going to use this function, not this function, and we're going to come up with the original parent function points. Non-shifted parent function. If I plug in -1, isn't that I? So we're not going to plug in -1. Let's start with 0. Square root of 0 is, square root of 1 is, square root of 2 is a decimal. Let's not use it. Square root of 3 is a decimal. Square root of 4, square root of 5, 6, 7, 8, 9. Square root of 9 is, let's do another one. Square root of, okay, that's enough parent points. Where did I get that from? The parent function. Now, what we're doing is we're shifting. There's no stretch or compression. We're going to right 1. So think about, that's taking all your x values and adding 1, correct? Add 1 to your x values and up 2. So that would be shifting up 2. So that would be adding 2 to your y values, right? So our new x, y points would be 1, 2. 1 plus 1 is 2, 3. 4 plus 1 is 5, what? 2, what the heck? Did we say that right? Yeah. Okay. 9 plus 1 is 10. 3 plus 2 is 5. Did I do that right? Yeah. 16 plus 1, 17. Okay. So let's graph those. Over 1 up 2. Over 2 up 3. Over 5 up 4. Over 10 up 5. And guess what? That was clear over here more, right? So on the test, if you don't plot every single point that can be plotted, you'll get it wrong. Yes. What do you mean? Oh, I see what you're saying. Yeah. So I'm okay with you doing a rough sketch as long as you have these written out. But on the test, I would expect an exact sketch. But if you've got those written out, you can do an exact sketch. So now let's do domain and range. Good question. Just do a rough sketch on the side somewhere. Domain. Look at the picture. It makes it easy. Wait. What the heck do I draw that down there for? Okay. Domain. Wasn't it right? This is a 1 up 2, correct? Yeah. So our domain would be 1 to infinity. Our range would be 2 to infinity, wouldn't it? Yeah. Okay, good. That's all you got to do. Okay, number 51, it says rewrite and describe the shifts. There are some like this on the test. So first of all, looking at this, should I just say write 63 up 4? Nope, there's a problem. What's the problem? 9. I'm not going to give you that hint on the test. I'm going to say, what's the shift from the parent function? You've got to recognize that 9 is a problem. So we factor out a 9. Divide by 9, divide by 9, so left is x minus 7, right? Yeah. Plus 4. So our final answer would be 3 root x minus 7 plus 4. So now in words, describe the shift. Right 7, up 4, stretch of 3. That's a whole section on the test. Doing that. Can we do that pretty easily? Okay, let's hope so. Okay, do 41 through 55 all. Ready, go. Look at 56D. Go to 56D. I'm going to graph this one with you. We really shouldn't be missing these because even if you didn't know how to graph them, you could plot X, Y points. Here we go. 56D. So everybody just focus on this. We know how this is a quadratic that's been shifted up 4, correct? Everybody go up 4, put a dot. Now it's reflected over the x-axis, so you could plot points. Let's say you didn't know these points. Just plug in some points here. But over 1, down 1, 2, 3. Over 1, down 3. Over 1, down 1, 5. So once again, you could just plot some points, which you're going to have these. So draw in your quadratic, everybody. Now it says we're only keeping that quadratic for x values less than -2. So you could go over to -2. Look, I'm going to locate -2 and highlight it. We're only keeping the function for x values less than, not including -2. So we're going to have to then go in and erase everything above it. Right? Everything above -2. So then you'll go to -2, everybody, and it does not include -2. So you're going to make sure you keep a closed, open circle, right? Okay, good. And then it's coming down, or there, it looks something like that. Now let's go on to graph this. An absolute value is a v. The shifting for all functions works the same. This is an up 4 shift. It'd be a shame to get it wrong because you messed up on a shift. And then the slope is 1. These are v's. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Then we're only keeping it for x values greater than or equal to -2. -2 is highlighted. X values greater than or equal to. So we're keeping this side and erasing that side of those dots over here. Okay, now it's including -2. So go to -2, go up to the function, and make sure it's closed off. All of your functions on the test will still be considered a function. So if it looks like, if you have things overlapping, then you've messed up somewhere. Okay? Okay. Make sure you can graph those. They should all be functions. Okay, so you're going to do 50. So basically that's finishing up the worksheet. Finish up the worksheet. The rest of the time is yours, but what I really want you to probably do is everybody go to problem 57 and try one of those. Make sure you can write that backwards.